Welcome everyone. We will start our session. This is the NMRG meeting for IETF 116. So some information for participants, for remote participants. I hope you're connected through the Meet Echo and that you should turn your audio and video off while you are not speaking or sharing. Thank you. For on-site participants, we would like to remember that there is an IETF policy for participants to wear a mask all the time, except if you are an active speaker, presenter, chairing. So please wear your mask while in the IETF meeting rooms. Also, even if you are attending in person, please log in to the Meet Echo. You have an on-site meeting tool. This allows to record the participation of the session. If you want to raise questions during the session, please also do that by joining the queue through Meet Echo, and I will manage the queue. And please keep your audio and video off, please. Thank you. So we have a number of not-well slides that we like to go through before going into the actual content of the meeting, but this is an important reminder for the different IETF and IETF policies. So the IETF follows the IETF intellectual property rights disclosure rules, and in these slides you have some pointers also on the behavior you're supposed to have with respect to IPR declaration in the context of the IETF. We have also some privacy and code of conduct. So as a participant and entity to any IETF activity, you acknowledge that written audio, video, and photographic records of meetings may be made public. Your personal information that you provide to the IETF will be handled in accordance to the privacy policy that you can find at the link on the slide. As a participant or attendee, you agree to work respectfully with other participants. If you are a witness or experiencing different issue with disrespectful behavior, you can contact the ombuds team or contact any member of the IRSG and RSG. So now also a reminder about the goals of the IETF, so Internet Research Task Force. We do conduct research. It is not in standards development organization. The IETF focuses on longer-term research issues related to the internet, while the parallel organization, the IETF, Engineering Task Force, focuses on shorter-term issues of engineering and standards making. So while the IETF can publish informational and experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, application, architecture, and technology. And if you want to know more a bit about the approach of the IETF in the context of the IETF, you have also a nice RFC you can look into. These are some useful links. You can access the materials of the meeting, access to the Meet Echo, and also the shared notes. The video of the session will be available later on the IETF YouTube channel. A bit of updates on the status of the research group, especially concerning, let's say, active documents. So for some time now, we have the Digital Twin Network Concept and Architecture document that is an adopted research group document. Let's say the new one that we have recently adopted, we are planning an official announcement of that on the mailing list, but we use the meeting to make this announcement. We have a new research group document, so the call for adoption was done earlier this year. So we have now a new research challenges in artificial intelligence for network management as a research group document. This will be changed to become draft NMRG AI challenges 00. We will ask the authors to proceed with that, and also instruct the authors to provide a new revision that will address the different comments and suggestions received during the call for adoption. Jérôme, the next speaker, will also have a few words on the comments received during the call for adoption. And we would like to really thank all the reviewers, people that have expressed different opinion and support for the adoption of the documents, and all the authors and participants to this discussion in the research group. There will be a bit more in the next presentation. Some other research group documents that are in the pipe. So these are not research group document, but individual draft, but they are especially looking into a different set of use cases related to intent-based networking. So there are three, let's say, IBN use cases that we have in the pipe for some time, but recently we have also two new drafts that has been submitted to the, for interest to the research group, network management intent, and one data transmission intent. So these are new drafts, but we have not yet seen, let's say, discussion on the mailing list or inputs from the authors about the next step for these documents. This will probably happen soon. What we like to suggest also, because this is an ongoing, let's say, work item for the research group, to start some dedicated discussion on the IBN use cases in the context of the NMRG. And also, we will invite for a dedicated interim meeting to address collectively the use cases aspect of intent-based networking in the NMRG. So this will be announced soon also. We will make some also research group announcement soon on the mailing list. So as I said, concluding the IBN items of the research agenda. I think we have covered most of what we intended to do for this topic in the research group, but we have still to go through this set of draft on use cases and see what could be the good outcome we want to produce with that. And for some time now, we have at least 3 topics that seems to anchor partly into the research group. So we have different activities related to AI in or for network management. This will be the talk, the 3 following talks. We have also network digital twin and green networking related aspects. Our discussion with Jérôme was to try to understand for these topics what the research groups wants to do about them, because these are pretty big topics. We have to understand what could be the value contribution in terms of research output for the research group, and to define this collectively so that we know also how to, let's say, steer our energy towards agreed outcome for these topics. So now entering a bit more the content part of this session. So this is the introduction and research group status I just gave. We will have a first part of the meeting concentrating on artificial intelligence and data for network management, where we have 4 talks. So a status on the newly adopted draft on the challenges. There will be Jungen presenting on the consideration for deploying AI services in a distributed approach. We will have a talk from Katarina on network dataset quality problem. And then Diego will present an approach they've been working on weaving Yang into a network data fabric. After that, we will have a presentation from Chris on network digital twin for the functional design aspects of performance-oriented digital twins. And finally, an update from Alex on the different drafts and, let's say, ongoing activities in IETF, RTF related to green networking. So that's the agenda for today. And I think we will directly jump to the first presentation that will be by Jérôme. Jérôme, do you have anything else to add before we switch to your presentation?
No, that's fine. Just to welcome everybody. Thanks for joining. So we can, I have no other comment. Okay, so Laurent, you share the slide, right?
Okay, you can see the slide?
Yeah.
Okay, floor is yours.
Okay, thank you. Again, I'll just say hi to everyone. So I will present here the status regarding this document about the challenges in coupling artificial intelligence and network management. Next slide, please, Laurent. We have an updated version, which is version 2 now, which was based, of course, of what we received already from the feedback from the call for adoption. So just as a reminder, so the call for adoption was based on the first version, so 0.1 version. It ended in February 1st. We got a lot of positive feedback, as you can see here. More than 20 people support the document. One was more neutral, and we received also detailed comment. And based on those detailed comments, we have the version 0.2 that that I will present now, or we address the different comments. Next slide, please. So of course, there has been a lot of, let's say, minor change and editorial changes. So we did a overall editorial pass in order to, there were some redundancies, some typos, and so. We have added also a list of, let's say, acronym in order to help for the reader. We have been, in the review we received, there was someone highlighted the ambiguity between AI and ML, AI and machine learning. So we had some, let's say, kind of a disclaimer to in the beginning of the document, the introduction, to make the distinction. We also corrected some because, you know, as it was a document with several, let's say, pass already before it becomes an individual draft. We have some issue. We try in section 4 to characterize each problem that we describe regarding some criteria, and for some of them there was some missing criteria, so we added it. We do some also the rephrasing to add some clarity in the classification of sub-challenges. And also we had some, so what I mean by external reference to papers or FRC also to highlight and to illustrate our statement in the draft. Next slide, please. So no areas change which are maybe not which are a bit bigger, I would say. So of course we received different comments regarding the distributed AI. Maybe as a reminder, this is also a section that we had in mind in the very origin of the document that we put a bit aside because we didn't have content at that time. But of course, the discussion arises again here, and it was totally justified. So we decided to address this by adding a dedicated, let's say, subsection with two subsections, I would say, in order to address both when we think about using distributed AI for network management problems, but also as distributed AI is distributed and that network is also distributed by nature, we also describe some challenge regarding the network management that can support distributed AI. So here you have some, let's say, citation from the text. I will not, of course, read now, but basically it's what we try to do here. Really, the two facets: the distributed AI for network management and network management for distributed AI. And so basically where we try to highlight that there are some challenges to have a good level of coupling between the two, let's say, the two level or the two planes, the network management plane and the AI plane, if you want. Next slide, please. Okay, so we also receive a comment regarding the relationship between AI-based network management and digital twins. So for us, basically, there are two topics that are different. Of course, you can have they are related, but they can, of course, can be used, for example, AI to run some digital twin networks. That's for sure, but it's not. Let's say it's not there. It's more kind of, let's say, a use case, I would say, in that case. rather than ready correlation. So we try to reflect that in the explanatory sections that I put the extract here. That both techniques of course can be combined, but there are differences in their let's say objectives somehow. Okay, I think Laurent, you give me the control on the slide, so I can go myself now. Thank you. So the next, let's say, change that we do is regarding the one, let's say, last section we have on the challenge, the document about AI-based products and algorithms in production system. We receive different comments regarding the lack of generalizability of machine learning algorithm and its impact on machine learning-based network management solutions. So that will be a problem if you want to have this system, of course, in production. So we elaborate a bit on these challenges regarding issue regarding data representativeness, different AI architecture, transfer learning, to highlight that some paths that are possible to go through. Of course, there is research needs to do, and that's why this is a document about challenges. We are not providing full solutions. It's not the goal of the document. And we also had, because we received different comments regarding interfaces, interoperability issues with AI and network management. So this is really, of course, we agree with that. This is very important if you want to have something that really runs into your system. So, and in production, you really need also to take care of that as well. So this is really important to have the right level of interface between, for example, the AI framework and network management framework that you will use. Of course, this is a bit also related to distributed AI. This was we tried to highlight in the document. Again, here I just put here's some extract of the text. I'm not reading just to it. Then after the presentation, you want exactly to go to the document and see what are the change. Here you have the reference where you should look at if you want to see where it is in the document. Okay, for other comment, okay, we received comments regarding to add more content on the discussion of specific AI machine learning method we should use to resolve such challenges. As I said before, we try to illustrate possible solution or paths for certain challenges. We had some reference to add that. We received also some comment regarding that this document, of course, should be, let's say, somehow addressed to our both, let's say, the AI people that we have a low level of understanding of network, and maybe the other way around, networking guy with maybe a lower level of, i.e., let's say, knowledge or skills. So this is something that we try also to reflect in the document to make sure to have the right level of, let's say, details and abstraction for, let's say, both. But of course, what we want to also here to highlight is that this document, the goal is really not to provide solution. Otherwise, it will completely change the scope of the document. So we just only put illustrative example. The exact mapping of for which challenges, what solution you should use. Actually, this is already a challenge itself. If you look into the documents, it's section 6.1. So we try to illustrate, but of course, it's not our goal, and it will not be possible to be exhaustive to say exactly for which challenges what we should exactly do in terms of, let's say, solution to be investigated, or AI algorithm to be used, and so on. We receive also the comments that it would be good to have the feedback from the operator. Of course, we will be happy to have more feedback from, let's say, operator side. So we encourage them to give their perspective on the current document. And like also, maybe just to remind that we have, of course, the author of the draft. We have several ones, but if you, just for the history of the document, this author are, we say, editors to, because we got different contributions from many people from different, let's say, perspective, academia, industry, operators, and so and vendors. And then this group of authors take this input from all these people already. So already incorporate some type of some of this feedback. Of course, it was in previous version, so now it will be good also to, again, we will be very happy to have also more feedback from the operator. And for next step, so I think Laurent, as you say in the introduction, so we are very happy because at the time we prepared the slides, there is no yet the official answer regarding the call for adoption. So as you say, so now it will become research group document. So for this step, it's done. So it's very good because, in our opinion, it's a very hot topic, the AI in all areas, including ours, so network management or networking in general. And it's good to have this document now and not to delay too much. So I think it's good that it become our RG document. So now we try to, as it's an RG document, try to have really periodic and frequent update to move fastly, maybe towards what it's our wish, at least towards informational RFC publication. And that's it from my side. So of course, if you have any question, I will be happy to answer. Just let me know.
Are there questions for this draft to Jérôme or the authors? This is a recently adopted research group document. I think it's, as Jérôme mentioned, that's been already pretty stable before becoming a draft. We are now at the second version of the draft. It's becoming adopted. And the idea is that if the content is stable and we estimate there is enough value to proceed, let's say, swiftly towards, to push it towards publication, if there is agreement with that. Any comment on the document? Everything's clear. Thank you, Jérôme. We'll switch to the next presentation. Jungen, you can go ahead.
Okay, could you hear me?
Yeah, we can hear you well.
Okay, thank you. Good afternoon. Nice to meet you again. I'm sorry to attend the Yokohama meeting because I'm another business, so I can't join the NMRG in-person meeting. Okay, this is the consideration of deploying AI services in a distributed approach. The version is the third version. Okay, next page, please.
You have the control of the slide.
Okay. Okay, thank you. Yeah, this is the history and status. Last year, we submit 0.0 version, first revision, second revision, and this year we published the third revision. And also, it is the third time presentation. The motivation of this draft follows. The first thing is to now we are targeting on the deployment of AI services. Until now, I remember that in IETF, we spent much time to find a possible standardization item in related working group, but it is not easy because performance server, but also small hardware, microcontroller, low performance CPUs, and AI chipset can be used for provide AI services. So to do this, we must consider the system network side to provide AI inference services. To do this, we consider not only accuracy of the model, but we also consider which is the best machine to provide AI services and what's the objective of the AI services. For example, the point is can be different. For example, accuracy, latency, network traffic, resource utilization, etc. So there are lots of consideration to do. For example, network computation, system computation, AI model, serving framework, communication method, device capacities, and the inference data, etc. So the intention, the motivation of these labs to accelerate the threat AI issue and find some possible standardization items in the NMRG. Yes, in the last London meeting, when I present this draft, I got two questions and one comment. The first question.
Okay, it seems we lost the audio from Yongan. Yeah, we can see you speak, but we don't have the audio in the room. Miteko guys, can you check, please? Yongan, can you try to speak again to see if it's better? Okay, no.
Hello.
Okay, it's back.
Hello. Okay, it's back. Okay, thank you. Sorry for the inconvenience. Okay, so the first question comes from the Alexander Klein. So he says that this trap is targeting on the system side, but he wants to see more network side. So in this revision, I try to reflect his command. The second question is come from by Jeff Tansra. So he mentioned the horizontal hierarchy because existing the document is describing the vertical hierarchy. And the last comment come from the person Campos Nobel. He says that it would be nice to have the similarity between this lab and the research challenge document. So I tried to reserve the three comments. Okay. So it is the update at the last meeting. So the compromise, the comment by Alexander Klein, I add a new section, so section 3.5, AI service, AI inference service on horizontal multiple server. So if you see the figure 6, the client can ask AI services the horizontal level 3 different AI server. So I guess that this section could be the possible solution to document the Alexander Klein. And the second update is to add section 3.6 network site utilization for AI learning. This contains
Sorry to interrupt. Can you try just to maybe mute and unmute or
also,
try to
sorry,
disconnect and reconnect because we have a very weird audio here.
Because network site utilization for AI learning or AI inference, I describe some possible text.
Or if you can withdraw from the queue and rejoin the queue as a speaker,
federated learning, etc.
Okay,
Yeah.
It's good now. Yeah, please go ahead. Can you try to continue now to see if the voice is okay?
Okay.
Yeah, it's good. Yeah, We hear you well now. Thank you.
So in the existing document, we have the 3 network configuration structure to provide AI services.
Okay.
And then we have 2 the vertical server configuration or 1 horizontal server configuration. So if we look at the ETSI group specification, MEC IEG 006 version 12121, mobile edge computing, market acceleration, MEC metric best practice and guidelines. When I see this document, I think if we it is better to have the similar document, because this document a good document to provide more the specific and the more general information how to provide the mobile edge computing in network or system side. So so I try to follow this style. So I add some the consideration, the functional characteristic of the hardware. So as you can see, okay. So I want to skip because it is the same to the last meeting. So the my last yeah, okay, this is. I remember that this comment leads to comment by Jefferson. So he want to make some align with the challenge document. So my answer is that this draft is also related to the challenge document, and some text can be added or merged. For example, distributed AI services, lightweight AI services, deployment AI services. So when I look at the challenge document, the distributed AI services and the lightweight AI services already exist. So I don't know how to handle the similar context. But I found that deployment AI services even is not exist in the challenge document. So if then deployment AI services could be inserted or could be added with the challenge document. Also, or I think that this draft can be deployed as a different document, because this draft is to focusing on the AI inference deployment of AI services, because the existing challenge document include many items, so the focusing point is a little different. Okay, this is the last page. So if some text could be added or could be inserted with the challenge document, for example, the network configuration structure, blah, blah, or consideration for configuring network, blah, blah, it can be moved to the right side existing section 6.3 and section 6.4. For example. So I don't know. I'm not the editor of the challenge document. So I want to ask, and I want to follow the decision of this the NMRG. Okay, that's all. Thank you.
Thank you, Jürgen. Do we have questions for Jürgen for the document on the distributed AI? Jürgen, for me, I believe it's good that there is, let's say, some alignment between your document and the challenges one on the of course, the topics that make sense. I don't see the need to have, let's say, for instance, too much integration of parts of your documents to the challenges. I don't think this is the goal of the approach, and it will not be beneficial to the research group. I think your document has been there for some time. What would be interesting to know is if you want to have it like a research group document, and what will be in fact the final form of this research. What will be the contribution you see the impact that this document will provide, whether it's a kind of a list of recommendations based on your experience to say, okay, if you want to go towards distributing AI services on constraints infrastructure, what could be the recommendation, the learnings. It could be also to have maybe some either use case or real field deployment experience that you want to share in the document. But I think we need to find a way forward for the document. I think it's pretty stable, pretty interesting what the content is so far, and to really make a good positioning in terms of the impact as a published document could be, and then we can move forward.
Okay, thank you for your comment. So some point I agree with your comment. So to do this, we need more time and we need more input. So I encourage other person who have interest of this lab, then it is very appreciated to join to drafting this work. Thank you.
Thank you, Jungen. Our next presenter will be Katarina.
Hello, can you hear me? Can you hear me?
Yes, we can hear you. Yeah, let me just bring up the slide.
Can I manage this presentation? Can you see my mouse?
Yeah, we have the slide on the screen and I gave you the control to move up the slide.
Okay, thank you.
So anytime you're good, we can start.
Yeah, but I cannot control. Okay. Hello, everyone. My name is Katarzyna Wasielewska. I am a researcher from University of Applied Sciences in Elbląg. I would like to spread the words about network dataset quality problem, and I would like to show you the method for dataset quality assessment. As my colleagues said before, the network management area needs novel solutions. We need fast and adaptive methods, and artificial intelligence can be helpful here. We can observe in research papers expansion of machine learning techniques, but it is still a challenge to create machine learning model that works in production. We have different algorithms, but those algorithms are based on data, and the results are as good as the data we use for training. And we can also notice in research papers complaints on the lack of the high quality data sets. And we can see also that researchers focus on model quality rather than the dataset quality, even though high quality data is the cornerstone for evidence-based decision making. And particularly assessing the quality of network dataset is overlooked area here, and I would say also that it is a neglected area. But what does dataset quality mean? It is difficult to say, it is difficult to give precise definition. Usually it is said that dataset is said to be of high quality if it meets the requirements for its intended use. It is quite wide definition, but generally we would like to have strong dataset, complete dataset which represent the problem very well, which is correct, precise, consistent, accurate, but usually we can meet many problems in datasets. For example, errors, noise, outliers. We can we often work with imbalance datasets. We can meet different tools for data cleaning in order to get rid of those problems from datasets, but it is not usually used in order to say that our data is representative or complete, for example. It is difficult to evaluate still these metrics. We can also meet sophisticated approaches based on entropy, metamorphism testing, and other methods, but it is not popular, not often used. And today, I would like to show you the method which we presented on conferences. This is PERCODA. PERCODA is based on the very old method called permutation testing. It is statistical method. This method is usually used for evaluation of significance of results based on resampling. I mean here arrangement of data in data sets. How it works in our method. First, we have our data set, original data set, with observations in X block and with label set. It means that we work here with classification problem. And in label set, we have labels represent classes that we recognize in our data set. We are doing machine learning pipeline on this data set, and we obtain performance results through results. And in the second step, we do a permutation. Permutation, it is shuffling, changing of position labels. It means that after permutation, we will have changed labels. For example, if we have if we have binary classification problem with two classes, we will have labels zeros and ones, and after permutation, some labels will change to some zeros will change to one, and some ones will change to zeros. As you can see, we use partial permutation. It means that we will permute only part of labels, and we will set permutation policy. And first, we will permute 1% of labels, for example, later 5%, 10%, 50%, for example, in order to have better picture on the problem and to check the sensitivity of our method and to be more accurate. We repeat permutations many times, for example, 100 times, in order to obtain some distribution that can be evaluated by other statistics. I will say about p-values later here. And this after permutation, we are doing the same machine learning pipeline as previously, but on the X block and YP, our new label set after permutation. And after this machine learning pipeline, we obtain performance scores after permutation. And we have, for example, for one classifier, 100 results. And we compare the results with original one, with true results. And it is expected that after changing of labels, we will obtain worse results because we think that we broke a structure, we broke relationship between X and Y, because we assume that our data set is strong and have a very good relationship between X block and labels. But it is not expected if we obtain better results after permutation than before, because it is signal that we have bad quality data set. It means that after introducing our methodology, we will obtain results in the table. For each classifier, from the pool of classifiers, we will have calculated p-values, and it will be calculated for each permutation level. For example, for 1%, 5%, etc. As you can see in 9th step. I will go later. In order to say something about this distribution of performance results after permutation in comparison to original results, we have to define null hypothesis. Our null hypothesis is that our data set is random. It means that we can change something in our data set and we never obtain good results. How to evaluate this hypothesis? We have to define p-value. The p-value is calculated as follows. we summarize the number of cases when we had better results after permutation than before. And we divided this number by the number of permutations. It means that if we permute 100 times our labels, we have 100 performance results after permutation. And if the number of better results is high, it means that something is wrong in our data set, and we cannot reject our null hypothesis. It is likely, we can likely say that our data set is crappy. But in order to be more precise, we have to set alpha. Alpha is threshold in order to say, based on p-value, if our results is significant or not. And if we set p-value is set usually to 0.05 or 0.01 if we want to be more sensitive. And if p-value is lower than or equal to alpha, we have evidence of statistical significance in results. But if p-value is higher than alpha, it means that our null hypothesis cannot be rejected. Interpretation is important here, because if we have pool of classifiers, we evaluate each results for all results, and if all models perform bad and we observe non-significance in results, it means the dataset is bad. But if some model will perform good, we will observe small values of p-values. We have significance in the results. We can say that dataset is good. And now I would like to jump to other slides. Here I prepared, I wanted to show you results based on the very simple dataset, toy dataset, and you can come back here after presentation maybe, but I will focus on network data now because of time. It is also important to say that if we recognize 1% of labels in small data set, we have a small number of labels for permutation. But if we have a huge data set, 1% means that we have to permute a lot of labels. It means that we have basis for change of our approach, and we permuted in the second policy, permutation policy, a number of labels regardless of dataset size. It means that we permute, for example, 1 label, 5 labels, 10 labels, etc., instead of percentage of labels. And I would like to show you one use case. It is in SDN dataset publicly available and prepared in SDN network. With this dataset has 70,000 normal observation and a lot of different well-known attacks. We considered here prop attacks, and we created balanced datasets with 2,000, 10,000, and 20,000 observations. It was 3 datasets, and in second step, we added to these datasets 5% of mislabels. It means that we directly change 0 to 1s and 1s to 0 for randomly selected 5% of mislabels, of labels. And it was 6 datasets already. And additionally, for the next 3 datasets, we introduced 10% of mislabels. It means that we had 9 datasets. Our permutation policy is as follows. As you can see, we tested the following pool of classifiers from different from different groups of classifiers. It is interesting that we didn't touch hyperparameters. It was set to the default. And we used in this experiment recall metric. It is important metric that can be used for security purposes, security problems, and we can control how many attacks had been detected. And as you can see, we had flows-based data without any information based features, no IP addresses, no port numbers, no private data, and we worked on this one. And I would like to show you results. Here we can see permutation charts. I have to explain a little this one. Diamonds represent true results. It can be seen then in first column without when we have dataset without datasets without mislabels, we have quite good or very good performance. And here you can see results of performance after permutation. We have 100 points for every classifier. And black points means that the results after permutation was better than before. And we can compare this with results on dataset with introduced 5% mislabels. We can see more black points. It means that in more cases we observed here better results after permutation than before. It is signal that something is wrong in the relationship between data and labels. And for 10% of mislabels, we see much more black points. And we also can calculate the slope of points because the higher quality of data set, the higher slope. It is proved, and the slope is calculated based on the regression line, and intercept is taken directly from the all intercepts calculated for each classifier, and maximum is the slope. The same information is reflected in p-value tables. We can see a lot of red numbers. It means that in these cases we had p-values bigger than 0.01, because here we set alpha to 0.01, and as you can see, in each case with mislabeled data, we had non-significance in results for 1, 2, 5, 10, 25 permuted labels. But for original data sets, we can see that we can say that these data sets are good, because we have some classifiers. Here, one classifier for 20,000 observation data set is performs good. It means that we can say that this data set is okay, is good quality. It is interesting because here you can see true results, and for all classifiers, for original data set, we have 100% of detected attacks. 100%, even if some classifier detected some problem in relationship between X block and Y. And in second column, with 5% of mislabels, we can see high results also, but without our method, it would be impossible directly say that this is introduced, because we did the change of labels from 0 to 1 from 1 to 0 for 5% of mislabels. And we often see these results in research papers, and often we are not able to explain why this results is not 1, for example. This method, Percoda, can help you check the problem in a relationship between X and Y. And here, for 10% of mislabels, we can also see quite high results. And as I told you before, we can also analyze slopes. It is scalar metric in order to evaluate data sets with numbers, and the worse data set, the lower value of slope for each case. Percoda, of course, doesn't detect all dataset problems. we are still not able to check if datasets cover a whole problem. We need a labeled dataset for this method. Percoda is affected by the possibilities of classifiers. We have different classifiers and we cannot control how they work. And also we have to deal with time computational costs, because if we repeat many times modeling, in case on this method we have many iterations, we have to wait longer for results. But if we want to obtain good information in the end, it is worth waiting maybe. We really need high quality data sets, and I think that there is the strong need to have cooperation between researchers and industry in order to go further. Suitable assessment of dataset quality is critical for building reliable, high-quality models. If we want to have models, useful models that can be put into real networks, and Percuda can be useful methods in the dataset quality assessment process, but it is not the method which solve any problem in datasets. Thank you very much. If you have any questions, please let me know. You can also contact me after presentation. If you have any feedback, comments, advice, everything what is related.
Thank you, Katarina. Very interesting presentation. Do we have questions to Katarina for the presentation? Okay, we allow the exception, Diego.
Thank you. Hello, good afternoon for us, and good morning for you, I guess. During the Open IETF, there was a presentation of a tool that is called Privateer that was analyzing as well how, well, it's not exactly the same because it's not about the data sets per se, but if I remember well, they were analyzing the way in which the learned models were somehow biased by the data. This is, I mean, looking at it, it looks like both approaches are quite complementary. Are you aware of this? Do you have any idea? I don't see.
Arthur is in the room. He's
Where?
behind you.
Yeah. So, well.
Maybe to give the context to Katarina, I mean, in a previous session in the IETF meeting, there was another paper presented by Arthur, which is also in the room here, presenting a framework for on trustworthiness of AI models, which, as Diego mentioned, there is a bit of complementarity between the two approaches. I think Diego is pointing to that, but
yeah,
do you want to phrase a question to Katarina, or it's more like
yes, no, I mean, it's precisely about whether she sees that there is some kind of evolution of all these tools to assess, and we were talking about this, to assess how data sets could be made available in a way in which they could be used for better characterizing models, evaluating models, etc. Because this Percoda currently is a tool that is, let's say, isolated and focused on whatever the data sets, right? Is my understanding.
Yeah.
Do you think this could be part of a mechanism for assessing on how metadata on the data sets about their usability or factability or whatever?
It is a difficult question because it is focused particularly on the relationship between observations and labels. This is the clue of this method. But unfortunately, I didn't see previous session, and I have to read it. But I believe that this is very important to check it. But back because maybe yes, it can be complementary work. Yeah, very interesting. Thank you.
I mean, Arthur is in the room. Maybe you can make a comment, Arthur. We have a bit short on time, but what I will invite is that this topic is of importance to the research group. We're planning anyway to invite for further discussion. So please, Arthur, make your comment. We will close the discussion after that, but we will re-invite for follow-ups on this.
Yes. Yes. Thank you. Thank you, Katerina, for the presentation. Really interesting work. Commenting on the previous question, I do think that the approaches are complementary and can be used together, especially because our approach looks a lot into the not between the correlations between X and Y as your work does, but a lot more on the how the X affects the Y in the classification process. One question I did have about your work is that you seem to look at the direct correlations between X and Y, and how in your assumption is that if the performance worsens after the permutation, then you had a good correlation between X and Y, and then that means that the data set is good. Did you take into consideration the dimensionality of X? I'm thinking if there's a lot of different features on X, there might be a lot of different spurious correlations that the data sets, that the models might still pick up after permutating the Y labels. Did you look into that, or was that a factor of your evaluation?
Thank you for your question. Not yet, but we realized that we have to check it. It is very interesting to manipulate X block. Of course, it is more complicated than changing positions in Y only. Yes, I'm totally agree. We have to work on it also. Yeah.
Okay, thank you.
Okay, I see that we have Marco also in the queue. I will leave the floor to Marco to ask a last question, and then we have to move on. Thank you.
Thank you very much.
Hi, Marco Tollini, Swisscom. So when you have a classifier, basically you are measuring the correlation between X and Y, right?
Yeah.
So if you make a permutation, which it's basically a random change, right? You are losing the correlation. So I would say that if you have a high, for example, recall, for example, in your example, sorry, is 0.95, I would say that that data set has high correlation. And if you make a permutation, you have lower correlation, and so lower recall, for example. So doesn't it mean that if you have good results in your classifier, the data set is also good because you have high correlation?
That's the problem, that if we have 0.95, we don't know why. We don't know why we have this, because if we have problems with correlation between Y and X, it is only one reason for this result. We can have other problems in dataset that affect modeling performance results. It is only one. Because I showed high quality data sets, and you saw 100% of detected attacks, and based on these we checked if we are able to detect mislabels. But if you have no perfect data set, it is difficult to say that the problem is lying on the relationship between X and Y.
I see. Thank you.
Yeah.
Thank you very much.
Thanks again, Katarina, for your presentation. Thanks for the questions. We have to move to the next presentation, Diego. And if you can make it slightly shorter, it will be very appreciated.
Thank you. So basically, this is this is an introduction to some work that we have started in Telefónica that is very much, well, it's connected with this work, but it's about trying to enhance the way in which we are moving around data to be applied in different contexts. Can you move on, because just So the idea is we're trying to build a data fabric, a general data fabric for, well, not only, I mean, network for network management in general. On the one side, we are very much focused right now on monitoring and how to integrate the different data sources and how to make the combination of this data in a way that can be useful for the different consumers, taking into account, among other things, and this is not well represented here yet. We are thinking about a better representation of this, because this diagram that you have here, we have been discussing with with other people, and it's not clear that a source can become a consumer, or a consumer can become a source in other cases. And well, the idea is that we are trying to go beyond what we have right now in terms of monitoring with Yang, and trying to make an integration of those data with other data sources, and, as I said, using this as a platform for the collaboration of sources and consumers. For this, what we are trying to follow is this data fabric paradigm that tried to produce, which is an abstract view of the data manipulation process, and facilitate the integration of new sources and new consumers in the fabric. For that, the idea is that we are following, one second, a forward to a graph model for implementing the data relationships. Now, please. So for this, and looking for something that is standard, we found that there is a ongoing standard that was created some time ago for facilitating IoT interactions, and has been around for a while. And and has been connected with some people that were researching in Telefonica as well, and that now are part of an organization that is called the Fireware Foundation, and this is NGSI-LD. NGSI-LD is a model for building this data fabric with an information model that is based on a labeled property graph, and that can be annotated with semantic information using the semantic web constructs, and as usual, serialized as JSON, because this is from the days of JSON. Right now, probably would have been serialized using CBOR, but it's from the days of JSON, and an API that is a REST API that provides information about the different contexts, the different schemas that are being used, basically, and support properties that are extremely interesting if you want to perform a complete exploitation of the data. For sure, the mechanisms for queries and subscriptions, and the temporal evolution. And well, it's totally this approach is neutral, architecturally speaking. Next one, please. We are making we are started with a mapping from the different data nodes on the NGSI meta model. Basically, containers are transformed. Well, they are entities and relationships and properties that belong to the entities of the relationships. And well, this is the initial mapping that we have done with some nodes, because containers are basically lists in more cases, and we associated it with something that has a list, or something that is related with another entity. The important thing is that we are trying to model certain leaves, some of the leaves, specifically the leaves that are associated with a reference with NGSI-LD relationships. Can you move on? As an example, here you have that there is a particular property there, which is the type of the interface. This is an example. We can discuss about this if you're interested later on. But it is that certain of these references are not just pointers, are modeled as entities themselves. So we can reason about these references, and we can provide something that is extremely important for us, that is the relationship among the different schemas, the Yang models that we are working with. Move on, please. So well, this is very fast, is about producing the different data stores that are now supported by Yang. We have found, and this was part of a long discussion on how we could model this. There is a data set ID featuring in NGSI-LD that allowed us to model this. And at the same time, we believe that this it will allow us to model and to support the idea that how we can make the digital twins collaborate using the same data fabric. Move on, please. We are now working on a prototype, just to experiment a little bit with the mechanisms we have defined so far for the mapping. And currently we are testing it with using Yang push and some virtualized Cisco routers. That is the ones that we have found that support NMDA. We want to focus on the translation aspects and not on the rest of things. And for example, today I learned that in the project, Thomas has run away, but you're here. In the project, there is a generator of Yang push, and this is something that we plan to use, and probably we will get rid of the Ciscos for the moment. Not that we have anything against it, but we prefer to make the people that are working this focus on the translation process and not in the data collection. Can you move on? And well, these are a list of research challenges that we have identified. What is be sure that this translation and the translation mechanisms that we have built are general enough. We have focused so far in a few models. We want to be sure that that these translation mechanisms are complete. Is how we can go beyond and to go to the other side. I mean, and considering other consumers and sources of data and make the whole integration in the data fabric. We have done so with Prometheus sources, etc. But we want to go into something more, a little bit more ambitious. For sure, we want to align with this work on with this Yang native connection with Kafka. And the idea is that some of the tools that we are currently using will be substituted by the tools that are being developed now, and to start a direct collaboration with the group that is working on NGSI-LD, because among other things, we have detected some details that would be desirable to evolve. And the last part, which is equally important for us, is that we want to, it's a full data fabric. We're not talking only about monitoring, but we want to address as well controlling. The other half of the control loop is something that we want to model as soon as we can. And that's all. Thank you.
Okay, thanks, Diego, for being quick. We have Pedro in the queue. You have a question, Pedro?
Yes, can you hear me?
Yeah, please, Pedro, be short because we still have.
Yes, I will be very short. Diego, I saw that in the prototype you are building on, I saw that you have a streamlined connection between the, let's say, the bus, the translator, and then the broker, and then the consumer. Why not connect all to the bus? You remember the work we did? You can translate and refeed to the bus, etc. You can do all that work within the bus. Why not? Do you know it, or just
first, I expected to have you here in person. You should be close to.
Yeah, anyway, that's I had a particular problem. I'm sorry.
Nothing, because Laurent is going to complain that we are talking about not. No, the idea, this was to illustrate the fact that the translator was writing to the broker. Using the bus for communicating them, for sure, is something that is well. In fact, in the current, I would say that in the current implementation, the broker is connected to the bus. So it's simply to show that there is a translation. No,
okay,
no more
this
than
is
that.
Conceptual. Okay. I understand. Thank you.
Okay, thank you. We have to move on for fairness to the other presenters. Thank you, Diego. Our next presenter is Chris for the performance-oriented digital twin.
Hello, good afternoon. So this is, and you can jump to the next slide. This is a companion to Jody Paise's draft presented in 2 iterations over the last 2 meetings on so-called performance-oriented digital twins. First, I'll do a brief recap of what that is. I'll get fairly quickly into the idea that the mapping of these twins to consuming applications or use cases is not unique. It's one to many. That gets into the idea of managing concurrent data sets and computing sessions with these twins. I'll talk about that. The real world aspect of dealing with variable networks, that is equipment composition, available instrumentation, and of course the whole usage of these things is to explore at least partly hypothetical scenarios, so that introduces variability as well. I'll talk a bit about performance engineering. Really the way to think of this is a walk through a real implementation, some lessons learned, and hopefully the idea is to sort of expand on understanding of the context and the concept. Okay, next please. So just to recall from the Paise draft from the last 2 meetings, the idea is that this version, if you like, of a digital twin is an analytical function or application. So, I mean, and of course it's a replica of the network, but it's not just a static copy or photograph. It's there to emulate behaviors of the real network, right? So something is saying, in this scenario, I want aspects of predicted performance of the real network. A large part of that scenario definition, it is a twin, will come from the state, status, composition, instrumentation of the network as it stands. But of course, it's what if scenarios, so at least generally at least part of what's being presented is hypothetical. Okay, and I'll talk about models that are inside that a little bit later. Now, of course, next slide, the digital twin architecture draft paints a more expansive picture of the function of a digital twin, but a way to consider that is you've got this kind of analytical function inside, and then you're completing that with what amount to other management functions. You have at least a closed loop based on the analysis provided by the twin or the performance-oriented view of the twin. Obviously, when you're going from intent inputs all the way to control outputs, there's a lot going on. In this work, that's referred to as a flavor of a, if you like, an active digital twin or a bidirectionally syncing digital twin. And next slide, please. Another way to look at that collective thing is it's a management plane or management and control system, right? And in that context, to borrow language from ETSI's ZSM, for example, the PODT is a management function. It provides a management service. It's an analytical one. There are consuming applications of the information it provides. Generally, they're providing scenarios. They're trying to find some optimized scenario based on the answers, conclude some kind of action to result. The thing I want to stress here is that you can have, in a realistic management system, you can have multiple twins of this kind, but in general, you're going to have multiple processes, functions that are interrogating this digital twin operating concurrently. Next slide. And one illustration of that, I'll focus on the flavor of performance-oriented digital twin that we brought in the last meeting as a first revision of the Paise draft, and that's the so-called optical performance digital twin. The function of this one, we have an optical transmission network, and the predictions of performance that we're after are optical transmission performance. So basically what's coming out is, in this given scenario of network, channel, optical channel, service configuration, etc., what are going to be the resultant channel powers, noises, and especially margins? How well are they going to work from a transmission perspective? And again, the 2 incoming arrows, these are basically, this is basically the input data. It's just meant to reflect that at bottom there are 2 sources. There's the data from the twin, and there's whatever you're substituting or complementing to define the what-if scenario that you're seeking to emulate. Okay, next. Now, in that draft, we said, look, there are a lot of use cases and therefore related management applications that will work with this thing, covering a wide range of operations automation or optimization on the optical network. So the one at the top, this is if I want to do channel add, drop, reroute. Basically, I want to find a formula of powers, batching, sequencing of operations that's going to give me operational integrity. I'm not going to drop continuing channels. They're not going to fall out of margin spec. I'm going to bring everything up in a way that it works. Risk mapping, if I simulate some fault and I look at the unaffected optical channels, will they still work in the current condition of the network? My restoration map, will it work, right? And if not, I can point to some, renewed restoration planning. And then we get into service planning, network planning, and these things all have some degree of embedded optimization. So repeated interrogations based on a hypothesis, performance information returned, decisions made leading to action. Next slide. The thing to note is that what distinguishes these applications is not the information coming out of the twin. And to first order, it's not the functional models that are involved. It's the scenarios presented for assessment that are different, right? So you get into this idea that, it's many to one. I've got a single twin which is supporting the concurrent function and the sequentially presented requests in large numbers from single application use cases. So how do we deal with that? Next slide, please. And of course, one of the key differences among these scenarios is what's real data reflected from the twin and what's part of the hypothetical scenario, right? So if we start with our provisioning optimization, then obviously the network is as it is, right? We're only changing channel configuration. There are existing optical channels that we are not touching, but we're adding and dropping others and optimizing their powers and the sequence in which we do things. If we go to network planning, right, we're playing with not only the mapping of optical channels to the network, but to some degree we're playing with the composition of the network. If it's brownfield or incremental planning, we've got existing network that's reflected by data from the twin, and then we're adding others. If it's greenfield, it's all hypothetical, right? So you get this mix. Next slide, please. And I don't see the clock, so I'm kind of winging it here. So obviously you get into this notion of you've got concurrent sessions that you need to operate with several implications. One is life cycle, right? Every one of these operations from each one of these applications has a life cycle that's driven by the consuming application. It can be a one-off computation, or in fact, it can be a continuing computation yielding changes in the answer depending on changes in the data from the twin network. Model composition, right? So, I mean, with each difference in scenario, we're going to construct what amounts to a different model from the atomic pieces. There may be considerations of computational order, where the data comes from. Some of the data may be real data from the network or presented a priori. Others may be the result of partial modeling, right? There may be a sequence of modeling steps. And of course, the data itself, at root, we have this master data from the real network, and that has to continue to evolve. It has to be available to all of these applications, but it has to remain uncorrupted by all of these scenario-based presentations of data for calculation. Okay, next slide. And here's some schematics from our own implementation. A few things that you see. Obviously, you've got tricks like we have session IDs attached to each computation, so we can track what's associated with what. On the data management side, well, we have to figure out depending on the answers that the characteristics of the scenario presented, we have to figure out a sequence of calculations using the models, therefore where we start with the data, and we decompose this into sequential operations. The so-called real-time data there, that's the twin data. So from this perspective, it's read-only. There's other things that can write that, but not these computations. Different levels of the computational sessions will create certain data that's selectively now available to the sort of superior sessions. And obviously these parallel sessions, if you can do that within a single computation for a single application, this just maps generally to concurrent support of many applications. Next, please. Just a little bit more, this idea of network variability. So, you know, first of all, from both the real network that you're twinning to, and then differences driven by the scenarios you're considering, driven by the use cases, there's going to be variability, right? You're going to have different equipment types. You may or may not have specific models for them. Depending on whether, you know, you've got a piece of equipment in the real network, you may have an instance-specific model, or at least a type-specific model. If it's purely hypothetical, the best you're going to have is a type-specific model. You might have a generic sort of functional model that you have to use. Similarly for data, there's going to be differences in, for example, instrumentation. On the optical network, we may have different types of points of power measurement, channel power measurements. What we'd really like is to have ubiquitous direct measurements of optical signal to noise ratios, right? The better instrumentation we have, the less modeling we have to do and the better answers we're going to have. But we can always flexibly use modeling with available instrumentation to get at the answers we want, right? If we have power measurements, we can use modeling to get to our noise, signal to noise ratios. From there, we can get to margins. Right. So this also gets at the idea that, you know, there's a clear sort of source of information preference hierarchy that we build in, and also the quality of data builds over time, and that with operational experience, if you like, and that's going to improve the quality of predictions over time.
Chris, we have to move to the conclusion, please.
Okay, yeah, sorry, it would have been helpful to have the clock up. Just the last slide. Obviously, for performance, if there's a lot of these things going on, single applications can present, you know, a sequence of many computations. Think of an optimization. So obviously, performance is going to be an issue. You want to use all the usual tricks in addition to the data management and the workflow management and linkages issues. But of course, the models can in fact usefully be on the network elements themselves, right? Because they have direct access to their own data, and they may in fact be a logical home for instance-specific models. Obviously, those need to be federated at the collective level, but that is an architectural possibility. Okay, that's it.
Thank you, Chris. Sorry for being short on time. We have to move on to give at least a few minutes back to Alex. Thank you.
Thank you. Now we're basically almost out of time. How much time do I have?
I mean, you have the remaining time for the end of the session. But after that, we can not keep people.
All right. So maybe I'll try to cut it from 10 to 3 minutes. So, okay. So this is an update on the challenges and opportunities in green networking. Next one, please. We presented on this one actually before in this in NMRG. Here, the purpose again is about analyzing challenges and opportunities in green, sustainable, carbon neutral, and support networking, as this is one of mankind's grand challenges, and actually it attracts increasing attention also here at IETF. We presented an earlier version of this before here. Next one, please. There have been various enhancement, refinements, additions. Actually, the document has grown significantly. We don't have time actually to talk about the details. Maybe go to the next slides. I don't know how much time we have. We probably will need to skip across this. Please take a look at the document. I should also perhaps mention tomorrow there is going to be a side meeting on environmental impact in networking. We will talk about this one there as well. If you're interested in this topic, please come there. We will hopefully a little bit more time to discuss these things there. But as far as NMRG is concerned, can you move on to the next one? Next one. One thing to mention here is there were two drafts. Actually, one is the problem statement and challenges and opportunities. The other one are green metrics. There's a companion draft. We presented green metrics in Ops AWG. That the green metrics draft is probably closer to standardization. So less of a research topic than the challenges and opportunities. So therefore, basically, the proposal, the request is basically to bring the green metrics draft to Ops AWG, and they're actually very receptive there, and have the challenges and opportunities for green, have that one be here, and basically have that be adopted by NMRG. This is actually really, I believe, where it belongs, and this is basically what I wanted to just put out there for the discussion. And sorry that we had to keep it so short, but I think this is the main point, and that I got to make that point, and perhaps requesting feedback on that, well, from the chairs and perhaps also on the mailing list.
Thank you. So the session is officially over, but if you want, we can still get some comments to Alex or the draft on the way forward for the problem statement and on challenges and opportunities and the location to the NMRG. Any comment on that? If not, yes, reiterate just that there will be a side meeting dedicated to environmental impact tomorrow. I think it's at 1.
It's tomorrow at 1
p.m. You can find it on the side meeting wiki of the IETF116 website. And so thanks you everyone for the attendance to the session. Thanks to presenters on-site and remote. Apologies to the last two presenters for cutting short on the presentation. We invite you also to share comments, questions, and have discussion on the mailing list. This is the central place for discussion of the research group. All the topics we have gone today will have follow-ups. So the AI challenges, distributed AI, data quality, dataset aspects, future positioning of digital twin in the research group, and green networking, all of those will be subject to specific communication to the research group to organize how we want to approach these research questions in the research group. So please stay tuned on the mailing list, and we will have also invitation for kind of follow-ups, interim meetings on an ad hoc basis. But thank you everyone. Have a good day. Have a good rest of the week.